So ratio and proportion. A ratio compares things. The things may be numbers, masses, amounts of money. For example, if we have 5 boys and 7 girls in a class, then we say that the ratio of boys to girls is 5 to 7. That's how we write it. 5 to 7. Uh, 5 to 7, or 5 over 7. Okay, this is the same as this. This is the same as this. So that's what we're saying. A ratio A is to B can also be written as common fraction A over B. So ratio like A is to B can be written as A over B. So this is the same as this. That is the same as that. To compare two or more ratios, you can rewrite them as common fractions with common denominator. For example, to compare 3 is to 7 and 4 is to 9. 3 is to 7 and then 4 is to 9. We are told to compare this. You need to just change them to the fraction, okay? So we have 3 over 7 and 4 over 9. Still, we can compare them because they are having different denominators. So we need to find um, same denominator by LCM. Okay. All right. So I think 60 or 63 will be the LCM, and then 7 goes into 63. If you want 9 times 3, 27, and then 9 goes into 63, 7, and then 7 times the 4, 8. So right now we have 27 over 63, and then 28 over 63, the same denominator, so we can compare them. So we can say that 27 over 63 is less than 28 over 63. Therefore, 27 over 63 is for what? 3 to 7, and then 28 over 63 is to 4 to 9. So this will be a final answer. Okay, yeah, so that's what happens under ratio and proportion. And so we are saying that the order in which the ratio is given is very important. So the thing that is given first in the comparison must be written first in the ratio. And so for example, the ratio of boys to girls is 5 is to 7. Now 5 is to 7, the ratio of boys to girls, 5 is to 7, or, or 5 or 7. So that's what we're saying. All right, so we know that a ratio sign is those two columns, 1, 2, and then ratios may be simplified by dividing each part by the same number. In some problems, the given ratio is not important in its simplest form. So we just change it to the simplest form first. Okay. So let's say we have 12. So we have an example like 12 is to 4. Okay. So ratios are just like fractions, and then when you have any ratio, you have to make sure it's in the simplest form. Okay, so that's what we mean. If you cannot cancel them when it's in this state, you can just write it in this state too. Okay, so this is the same as this. As we started, we said, okay, so 4 goes here, 1 goes here, 3. So right now we have 3 is to 1, which will be your final answer. Okay. All right. So another example. Let's say 6 is to 2. So write 6 over 2 2 goes here, 1, 3. Right, so right now we have 3 is to 1. Okay, so that's what we are saying about ratio. And so multiplying each part of a ratio by the same numbers will gives an equivalent ratio. Okay, so just like equivalent fractions. So we are saying 2 is to 3 is equivalent to 4 is to 6. Okay, so we are saying this 2 is to 3 is equivalent to 4 to 6. Why? Because when we multiply 2 by 2, we get 4. This 4. And then when we multiply 3 by the same 2, we get what? 6. That is why we are saying it's equivalent. So check my fraction video to understand what we mean by equivalent fraction. Okay. All right. So to express two quantities as a ratio, they must have the same units of measure. Okay. All right. Um, so we are saying that um, 4 kg to 1 kg. Okay. So 4 kg to 1 kg. You can work this out because they both got what the same units. Okay, but you can't work this, let's say 4 kg and let's say 40 grams. No, because this kg and g, so you can't work them. You can work this out, but you can't work them. The 4 kg and then to 40g because of differences in units. Okay, all right. So um we need to study these um, conversions. Okay, 1 minute is 60 seconds, 1 hour is 60 minutes, 1 hour is 3,600 seconds, 1 kg is 1,000 grams, 7 days is 1 week, 52 weeks is 1 year, 12 months is 1 year, 1 kilometer is 1,000 meters, 1 meter equals 100 centimeters, 1 meter equals 1,000 millimeters, and then 1 centimeter is equal to 10 millimeters. Our first example, in a class of 30 students, 12 are girls. What is the ratio of boys to girls? And so we are saying that in a class there are 30 students, okay? And girls are 12, but the boys we don't know. So we can go ahead to find the ratio of boys to girls unless we're able to find um, how many are boys. Okay, so you just need to subtract the girls 12 from the 30, the whole class. Okay, all right. So what are we going to get? 18, right? All right. Now we know that the 18 is for what? The boys. Okay, all right. So right now you can write it this way: girls 12, and then boys are 18. What is the ratio of boys to girls? We need to turn things upside down because it's boys to girls. That's what we made mention earlier on. Okay, so it's what? 18 because boys first, to girls 12. This will be the final answer. But then, as we said ratio is just like what? Fractions. Always make sure you break things down. Okay, simplify them. Okay, so I think 6 can work through. 6 goes here, 3 goes here, 2. So 3, 2. So final answer. Okay, 18 to 12 could have been written as 18 over 12. Okay, 6 goes here, 2 goes here, 3. 3 over 2 is also 3, 2, 2. The same answer. Okay. Okay, with our second question, we're saying that express the ratio 20 centimeters to 15 meters in the form 1:9. So what it means is our final answer needs to be 1 is to a number. Okay. All right. So first of all, centimeters, meters. We said that if they have different units, we can't work them unless we do what? We change to the same unit. Okay. Right now it said 20 centimeters to 15 meters. This came first, so that means we need to change the meters to centimeters, then we can work them out. Okay. But if it was to be the other way around, like 15 meters to 20 centimeters, then we would have changed centimeters to what? Meters. I hope it's very clear. We always have to make sure the second one is changed to the first. Okay. All right. So first of all, let's change. We said we know that 1 meter is equal to how many centimeters? 100, right? Okay. So if so, we want to change 15 meters to centimeters. So 15 over 1 over this is equal to, we don't know, we are yet to know, and then 100. Okay, cross multiplication. So s is equal to 15 by 100 times 100 will give us what? 1500 or 1005. Okay, all right. Now we have new numbers here: 20 centimeters to 1500 centimeters, no more meters. So right now we have the same um units. Okay, so we can go ahead and work our way out and then make sure our answer is 1:n, a number. Okay, all right. So we can use, let's say, let's divide. Let's cancel. The easiest way is to just divide 1500 by 20, and then we get 75. So this can also be written as 20 1500. These are cancellers. Then we got what? 75. Okay. So we are saying when we cancel here 1 centimeter to 75 centimeters. Okay. This will be the final answer. And then it was saying the final answer should be in the form 1 is to a number, and then 1 centimeter to this number 75. Okay, all right. So there's the final answer: 1 centimeter to 75 centimeters. There is another question: solve for s. In the question, 6x to 64 equals 18 to 32. Okay, so whenever you have these kind of questions, you can write it in this form: 6x over 64 is equal to 18 over 32. So 6x over 64 is equal to 18 over 32. And then we just do cross multiplication. Okay. Or 6x is to 64 is equal to 18 is to 32. Always the very first number multiply the last number, and then the second number multiplies the immediate next number. Okay, so this is the same as that. Okay, all right, so let's continue. So 6s will multiply 32, then it's equal to 18 will multiply 64. Okay, so 32 times 6 will give us 192x is equal to 18 times 64,152. Okay, yes, divide both sides by 192 to get the x. So 1152 divided by 192. So x is equal to 6. We found x now, okay, because I solved for x. X is 6, okay? Yeah, okay, let's try to solve for x in this question. 4 to x plus 5 is equal to 1 to 2, okay? All right, so the same process, 4 over x plus 5 is equal to 1 over 2. Do cross multiplication, okay? So x plus 5 times this one, then 4 times this 2, okay? And so x plus 5 times 1 will give us what? X plus 5, okay? 4 times 2 is 8. Now x will stand alone. 8 plus 5 jumps over the equal sign will tend to be minus 5, okay? Final answer is 3. So our S for this question is what? 3. We jump to the subtopic proportional division. And we are saying it's about dividing or sharing something in a given ratio. So the ratio tells you how to do the sharing. So we divide something in a given ratio, we find the total number of parts for the ratio. Okay, so the ratio S to Y gives S plus Y parts. Okay, we are saying S to Y will give what? X plus Y parts. Okay, alright, so the ratio S to Y to Z gives S plus Y plus Z. We had it from S to Y to Z. Okay, alright, so the share corresponding to x can be found by using the fraction x over x plus y plus z. Similarly, the share corresponding to y is given by the fraction y over um, x plus y plus z. So when we are talking about x, we write the x, then over x plus y plus z. Okay, we are dealing with y, we will write what? Y over s plus y plus z. When we are dealing with only z, we say what? Z over x plus y plus z. That's what we are talking about. Okay. When you want to find one part of a ratio, okay, that's how you work it. So if you want to find only x, you bring the s as the numerator, the rest will come down there. The same thing applies to the rest of it. Okay, let's work some examples and then we will understand what all of these things means. Okay, so a man divides his 360 cattle between his sons in the ratio 7 is to 6 is to 5. Find the smallest share. Okay, so logically we know that how many sons does this man um, have? One, two, three, 3 sons, right? Okay, and then the question says we should find the smallest, and then we know that the smallest is what? 5. Okay, all right, so 5 over 7 plus 6 plus 5 times 360. Okay, so what we were saying earlier on, that x over s plus y plus z, or y over s plus y plus z. This is the meaning, okay? Or z over s plus y plus z. So yeah, let's continue. So 5 over, let's say 7 plus 6 will give us what? 13, and then 13 plus 5 is 18. So 18 then times 360. And let's do some cancellation. Let's see. Okay, so 18 goes here, 1 goes here, 20. Okay, so 5 to 10 and 100. And then we know that the smaller share will be what? 100. Okay, yeah, so that will be the answer for the question. Okay, so let's say if the question was like find the highest share, highest is what? 7. So it would have been what? 7 over 7 plus s plus 5 times 360, and then you work your way out the same way. Okay, yeah, so if you have any questions, if you don't understand, please comment and then I'll go over. The price of $300 is shared among Fogg, Wright, and Lord in the ratio 4:3:3 respectively. How much did Fogg receive? So if it's respectively, then first name Fogg is for the 4, 3 is for the right, then another 3 is for the Lord. Okay. All right, and then the question is how much did 4 receive? So we are looking at the 4. Okay, so 4 over 4 plus 3 plus 3 all over the $300. Okay, 4 over 6 10 times 3 0 4 3 12 or 120. How much did 4 receive? 4 received $120. Final answer. Okay, very simple. Increasing or decreasing a quantity in a given ratio. A quantity can be increased or decreased in a given ratio by multiplying it by a suitable fraction. If the price increases in a ratio 3 to 2, then multiply by the fraction 3 over 2. Very simple. Okay. Yeah, let's see this example. So it says we should increase $450,000 in the ratio 7 to 5. So just 7 over 5 multiplied by what? The 450,000. 5 goes here, 1 goes here, 9, 5, 9, 45. So right now we have 90,000. Okay, okay. And then you just multiply by 7. So 7 times 90,000 is this, um 630,000. You see, increase 450,000 in the ratio 7 is to 5. It was 450, but right now it's 630,000. So we have increased to the ratio 7 is to 5. Very simple steps. Okay, decrease 60 kilometers in a ratio 5 is to 8. This time around, we have to break it down. We have to decrease it. Okay, so let's see. Question 2. 5 over 8 times 60. Okay, all right. We can't, yeah, we can cancel about plus 5 times 60 is what? 300, right? Because 5 says 30, and then plus the 0 over 8. Now let's divide 300 divided by 8. We have 37.5. Okay, so it was 60 kilometers. Now it's 37.5 kilometers. We have decreased it, and this time around, it's not of the same what it's not the same 60 kilometers. Yeah. Let me bring it dollars. Okay. All right. So yeah, easy stuff. We move to the subtopic proportion. And we are saying proportion is another name for ratio or fraction, and it is important that the same units are used. It is sometimes more useful to represent a proportion as a percentage. Okay, so let's work some examples. In a manufacturing process, light bulbs are being made. 150 bulbs are rejected in a batch of 30,000. What proportion of bulbs in the batch is satisfactory? So we are saying that proportion are more useful when they are in percentages. So our final answer will be in percentage. Okay. All right. Um, there is a batch of 30,000. 150 bulbs are rejected. So in order to find the good ones, the ones that were not rejected, we need to simply subtract the 150 from the 30,000. Okay. So 30,000 minus 150. 30,000 minus 150. Okay, so we have 29,850. Okay, so these are the good bulbs. Okay, all right. And then we are saying what proportion of bulbs in the batch is satisfactory. So that means we are looking for what? The good bulbs. And then right now we have it to be 29,850. So 29,850 over 30,000. Okay. All right. So this can also be written as what? 29,850 is to 30,000 as a ratio. Okay. All right. All right. So let's do some cancellations. Looking at it, let's say maybe um let's use 150. Okay. So okay, so 150 goes into 30,000 200 times, and then I'm going to 29,850, 199 times. So we have 199 over 200. Okay, but what we are saying is in proportion, it's useful to always have a answer to be in a percentage form. You can't just leave it like this. Okay. So in order to have it in a percentage form, you just easily have to multiply it by what? 100. Very easy. Okay. So 0 cancel 0, cancel 0. We have 199 over 2. 199 divided by 2. Our final answer is 99.5%. Okay. Or you can round it up to this 5. So plus 1 is what? 100%. Okay. So this will be the final answer. Sometimes you just have to check, when we have options like A, let's say 20%, B, 90%, C, 99.5%, D, 40%. What are you going to opt for? That's right, C. Correct. But then if we don't have 99.5% and then we have 100%, you just have to be smart enough to know that the answer is this. You worked your way out and then you had this. Yes. But probably they rounded it up. They had 100%. So still you have to pick your answer to be C. Okay. Yeah, so um yeah. If a car uses 2 hours to consume 10 liters of gas, how many liters of gas is consumed in 5 hours? I 30 minutes. Okay, so we are working in hours. Now let's do the I. Unit is hours. So we can work them. Okay. All right. So we are saying that 2 hours equal to 10 liters. Okay. Then the question said 5 hours will be what? Okay. All right. So 5/2 hours. If more, less device. If less, more device. So 5 is more. So the lesser one will divide it. Okay. All right. Times the 10. So we will say 1. We will say 5. 5 times 5, 25. So how many liters of gas is consumed in 5 hours? 25 liters of gas is consumed in 5 hours. Okay. All right. Let's work I. The same process, but this time around we have minutes, then we have hours. So we have to change the minutes to what? Hours. Okay. All right. And then we know that 60 minutes is equal to 1 hour. But then there's 30 minutes. And so it will be what? Half an hour, right? So half hour. Okay. All right. So 2 hours is equal to 10 letters. And then we are saying we are working for what? Half an hour. If less, more device. If more, less device. This less. So over the big 2. Okay. Times the 10. All right. So we have 1/2, all over 2, or half over 2. Let's write it this way. 1/2 divided by the 2 over 1. Let's change it. 1/2 times 1/2. If you watch my fraction video, you understand what we are doing here. Okay. All right. 1 times 1 is 1. Then 2 times 2 is 4. So right now we have 1/4 times 10. Okay. And then we have 1 times 10 is 10/4. So when we divide 10 by 4, we get 2.5. So how many liters of gas is consumed in 30 minutes? 2.5 liters of gas is consumed in 30 minutes. Okay. So under direct proportion with these kind of examples, we say that if two quantities vary but remain in the same ratio, they are said to be in direct proportion. Okay, they increase or decrease at the same rate. Therefore, if one quantity is doubled, then the other is doubled too. If one quantity is halved, then the other is also what? Halved too. Okay, so to solve some direct proportion problems, you may have to find the amount for 1 unit of a quantity first. Okay, that's what we did here. We wanted to find 30 minutes, so we had to change to what? Half an hour, make it the same, and then work our way out. So these are some of the examples under direct proportion. We have another subtopic, inverse or indirect proportion under ratio and proportion. And then we are saying if two quantities vary such that as one increases, the other decreases, then they are said to be inversely or indirectly proportional. We have a question here. If 15 boys can do a piece of work in 60 days, how many boys will be required to complete the same work in 20 days? Now, if 60 days is equal to 15 boys, then 20 days will require more boys to complete the same work, right? Yeah, because if we have 60 days, 15 boys completed it in 60 days, then how many boys will complete in 20 days? Okay, so 60 or 20 times the 15. Okay, this zero cancels this zero, 2 goes here, 1 goes here, 3. 3 times 15 is what? 45. Okay, so we will need 45 boys to finish the work in 20 days. Logically, if 15 boys had to strike through 60 days to finish the work, then 20 days, we definitely need more boys to do it. So it makes sense, 45 boys. Okay, another example. A motorist takes 30 minutes to complete a journey when he travels at 60 kilometers per hour. How long will it take to cover the same distance at 50 kilometers per hour? So if 60 kilometers per hour is equal to 30 minutes, then 50 kilometers per hour will require more time to cover the same distance, right? Yeah. So if 60 kilometers per hour equals 30 minutes, then 50 kilometers per hour will be how many? So it will be 60 over 50 times the 30. Okay, so the 0, 5 goes here, 1 goes into 36, 36, 36. So how long will it take to cover the same distance at 50 kilometers per hour? 36 minutes. Okay, in the exams, you'll get something like this. These are some of the questions you'll get in the exams, and then sometimes they'll put it in a sentence form. Okay, so when you get something like this also can be written as 7 is to 10, then this is what? Equal sign 14 is to x. Okay, or you can also change it to 7 over 10 is equal to 14 over s, and then you cross multiply, and then you continue working. Or always the first number multiplies the last number, and then the second number multiply the immediate number close to it. Okay, so if you are running out of time, no need to be writing it in this form, and then where you just visualize this times this 7s, then 10 times 14, right? 140, then you cancel, you get your answer. Okay, all right, so let's try to work this. So 7x is equal to 140, right? So 7, then 7, 2, so 20, that is 20. Okay, so these are some of the very questions you'll get at the HESI too. Yeah, so that should be all for ratio and proportion. If you have any question, let me know under the comment section. And